Hello students, welcome to RHchemistry. So in today's video, we are going to discuss about Chemtonics number 13. So if you have not seen remaining 12 series in Chemtonics, please go through all those because all those are very important, explained in the very simple language for NEET, JEE or KCET. So in today's Chemtonics, let us discuss about equivalent mass. Right? So what is equivalent mass? How to calculate the equivalent mass for the different substances? What is normality? Such things we are going to discuss in today's class. Yes, my dear students, equivalent mass is nothing but it is the mass of a given substance. Correct ಆಗಿ ಅರ್ಥ ಮಾಡ್ಕೊಳ್ಳಿ. Mass of a given substance which will combines with or displace fixed quantity of another substance. So equivalent mass is the mass of a given substance which will combines or displace a fixed quantity of another substance. Or it can also be defined as a number of parts by mass of a substance, any substance that combines with 1.008 parts by mass of hydrogen, 8 parts by mass of oxygen or 35.5 parts by mass of chlorine. This is a standard definition, remember. There are so many methods to calculate, experimental methods we have to calculate equivalent mass. But those things which are not needed for NEET JEE, only we have to know how to calculate equivalent mass. So this is a standard definition. It is a number of parts by mass of a substance that combines with 1.008 parts by mass of hydrogen or 8 parts by mass of oxygen or 35.5 parts of chlorine is called equivalent mass. Now in this particular case, this can also be given like this. Here you can see number of parts by mass of a substance which will combine with 1.008 grams of hydrogen or 8 grams of oxygen or 35.45, nothing but 35.5 grams of chlorine. This can also be given like this also. So here you can see 8 gram of oxygen, 1.008 gram, equivalent mass of A, which means any substance equivalent mass is nothing but which can displace this much hydrogen or this much oxygen. Nothing but equivalent mass of A is displacing this much equivalent mass of the B. That is also you can define. So I will give you one example, right? So just consider we are having two reactions. One is C plus O2 give rise to CO2, right? So another one is, remember, C plus O2 give rise to CO. So here balancing 2C plus O2, 2CO I will consider, C plus O2, CO2 I have considered. Now I will calculate here in this particular case what is the equivalent mass of the carbon. Oxygen is constant but carbon we will see. See here the mass of the carbon is, remember, 12 gram. Mass of the oxygen is here 32 gram because 16 is the atomic number. Here remember 24 gram reacts with 32 gram. Now calculate. See here the calculation goes like this. 32 gram of oxygen combines with 12 gram of carbon, so that number of parts by mass of the carbon which is combining with 8 gram of oxygen I want. Correct? So now you calculate 8 into 12 divided by 32. You will get the answer as 3 gram. Which means equivalent mass of the carbon in this reaction is, remember, 3 grams. Now here you calculate, similar calculation you will get. So 32 gram of oxygen. So displaces, so reacts with 24 gram of carbon. So that 8 gram of oxygen give rise to 8 into 24 divided by, so 32, you are going to get the answer it as 6 gram. See here equivalent mass of the carbon is 6 gram. Here equivalent mass of the carbon is 3 gram. I hope you have understood what is the meaning of equivalent mass. Fine. Let us go to the next concept. Equivalent mass, how to calculate in case of acid base reactions. So in case of the acid base reactions, how to calculate? See, the equivalent mass of an acid is given as, remember this formula, very simple, molecular weight divided by basicity of an acid. So this is the formula. Then what is basicity or proticity? Basicity or proticity is nothing but, remember my dear students, it is the number of replaceable hydrogen atoms in an acid. It is the number of replaceable hydrogen atoms in an acid. That is nothing but, so it is basicity. That basicity you have to consider here, molecular weight by that basicity give rise to equivalent mass of the acid. For example, we will say, now I want to calculate equivalent mass of H2SO4 sulfuric acid. So in this particular case, what is basicity? Basicity is nothing but, in this particular case it is 2. These 2 hydrogen is replaceable, hence basicity is 2. We know that molecular mass is equal to, remember, 98 gram divided by 2, so that you are going to get it as 49 gram as equivalent mass of sulfuric acid. Very simple, isn't it? Now it takes HCl, equivalent mass of the HCl 35.5 divided by, remember hydrogen, only one hydrogen is present, basicity is equal to 1, so that answer become 35.5 only. Like that, calculate for acetic acid. Yes, acetic acid formula, CS3COOH, remember, equivalent mass is equal to, in this particular case, acetic acid molecular mass is 60 divided by, what is the basicity here? What is the basicity? Tell me my dear students. Yes, it is not 3 plus 1, 4. Basicity is not equal to 4. Basicity is only this hydrogen 1, because this hydrogen is non-replaceable. You cannot replace that. Replaceable hydrogen, how to calculate if you ask me? For example, if you add a base to this, what will happen? CS3COO Na is going to form if I add NaOH, which means only this hydrogen is replaced. Hence, I can call this as basicity 1. So, 1 is equal to 60. Like that. If you want to calculate HNO3 molecular mass is 63 gram, calculate. So, is equal to 1, basicity is equal to 63 gram. So, this is nothing but, remember, equivalent mass of the acids. Yes. Let us go to equivalent mass of the base. So, equivalent mass of the base is very simple, molecular weight divided by acidity of the base. Now, acidity is what? Acidity is nothing but, it is a number of hydroxyl ions in the base. Number of hydroxyl ions in the base. Now, you will see some particular examples. For example, I want to calculate, remember, equivalent mass of sodium hydroxide. Sodium hydroxide molecular mass is 40, because sodium is 23 and oxygen 16 and 1. So, divided by 1 I will write, because 1 OH is there, that is basicity, acidity become 1. So, it is equal to 40 gram. Very simple, correct? So, like that, KOH also can you calculate? Yes. KOH molecular mass is 56 divided by 1 is equal to 56 gram, because KOH molecular mass 56 and 1 OH is there, like that. For example, AlOH thrice, can you calculate? AlOH thrice, remember. So, molecular mass of AlOH thrice is, remember, 78 divided by 3 you have to do, because 3 OH groups are there. So, is equal to around 26 you will get. Similarly, barium hydroxide is equal to, barium hydroxide weight is 171 divided by how many? 2 is equal to what? 85.5. Like this you have to calculate equivalent mass of the base. Yes, next concept, equivalent mass of the salt, how to calculate. Very simple, equivalent mass of the salt is equal to molecular mass divided by, remember, total positive valency. Total positive valency, very simple. Correct? So, total positive valency, which means, for example, I will calculate equivalent mass of NaCl. I want to calculate it for NaCl. NaCl molecular mass is, we know, that is 58.5 divided by, what is the positive valency? See, Na is plus 1, correct? Positive valency is 1 then. So, answer for this is, remember, 58.5 gram. Like this. For example, another example I will give. Equivalent mass of, I want to calculate Na2CO3. Na2CO3 molecular mass how much? Calculate. 106 you will get. Right? So now you can see here again plus 1 I cannot take. You can ask me, sir, here also sodium is there, here also sodium is there, why not 1? But what is the formula? Total positive valency, total positive charge you can call it as valency or charge. Now 1 sodium plus 1 sodium plus 1, but 2 sodiums are there, hence it is plus 2, so is equal to 2. 106 divided by 2 is equal to, remember, 53. You will get the answer, 53 grams. Right? For example, BaCl2 you calculate. BaCl2, molecular mass of BaCl2 will get it as 208 divided by. So now you can see Ba2 plus charge, correct? 1 is there, 2 plus is there, so divided by 2. Total positive valence is 2. So the answer for this is 104 gram. Like this you can easily calculate equivalent mass of the salt also. Yes, next, equivalent mass of the oxidizing agent or reducing agent. Now, equivalent mass of the oxidizing or reducing, in both the case, remember, it is equal to molecular weight divided by, correct agi artha madkoli, molecular weight divided by total number of electrons gained or lost. Total number of electrons gained or lost. Generally what happens? Oxidizing agent or reducing agent, it will give the electron or takes the electron, correct? So total number of electron changed for that particular element you have to calculate. So that is give rise to equivalent mass of the oxidizing agent or reducing agent. Fine. So we'll take one example. Yes. First we'll consider KMNO4 oxidizing agent. Right? We know that KMNO4 oxidizing agent, it will oxidize in three different ways. One is acidic medium, basic medium and neutral medium. So now first we will consider, remember, acidic medium. If it is acidic medium, so remember KMNO4 changes to Mn2 plus, right? If it is basic medium, remember, if it is basic or alkaline medium, MnO4 2 minus. KMNO4 changes to, in case of the neutral medium, remember, in case of the neutral medium, it will changes to MnO2. Oxidation state calculate madi here. So here it is plus 7. Plus 7 to plus 2 means, remember, number of electron changed is equal to 5. Here plus 7 to oxidation state of the Mn become plus 6 here. So number of electron changed is equal to 1. That we also called as n factor antanu kariತೀವಿ ನಾವು. Plus 7 to plus 4 here. So number of electron changed is equal to n is equal to 3. Which means in case of the acidic medium, now KMNO4 molecular weight is how much? Molecular weight is equal to 158 grams. Remember, 158 gram. Here it become 158 divided by 5 is equal to around 31.6 you will get. Here 158 divided by 1, so that you will get 158. Now here 158 divided by 3, almost you will get it as 52.6 grams. Which means KMNO4 will have different this equivalent mass in different medium. Acidic is different, basic is different, neutral is different. Understand this. So another example we will see, second one, that is potassium dichromate, K2Cr2O7. K2Cr2O7, when it is used as a reducing oxidizing agent, remember, it will form a compound in Cr3 plus charge. So here chromium is plus 6 charge is there, here plus 3, but 2 chromium is there, so that total unit change is, remember, 6 unit change. 6 unit change means molecular mass of K2Cr2O7 is equal to, remember, 294 you will get. You can calculate 294 you will get. So that equivalent mass is equal to, you will get it as 294 divided by 6 is equal to 49 grams you are going to get. See, very simple. Like this, remember, you are going to get this particular, the potassium dichromate. Yes. Now you will take one reducing agent, FAS, ferrous ammonium sulfate. Ferrous ammonium sulfate is what? See, ferrous ammonium sulfate is like this. NH4 twice SO4 dot FeSO4 dot 6S2. It is ferrous ammonium sulfate, that is double salt. In this case, remember, molecular weight is equal to, you are going to get it as almost 392. I have already calculated, so I will write it directly. You can calculate it. Now, whenever this particular FAS act as a reducing agent, when it act as a reducing agent, so here Fe is in +2 state, correct? So Fe plus 2 converted into Fe3 plus, which means how many electron change? Only one. So hence remember, equivalent mass become equal to 392 divided by 1 is equal to 392 gram. Like this, remember, you are going to get this particular equivalent mass. Yes, this is about equivalent mass of the substance. Now we will see what is normality. So normality is related to equivalent mass. Hence I have considered normality along with the equivalent mass concept in this particular case. Yes. Now you can see normality is nothing but which represent the number of equivalents. Number of equivalents is nothing but you can call it as gram equivalent, because we will express this in gram equivalent per liter of the solution. Normality is equal to, can also be written as number of gram equivalent of the solute divided by, so you can say in this particular case, volume of the solution in liter. Just if you remember what is molarity, molarity once ನೆನಪು ಮಾಡ್ಕೊಳ್ಳಿ. So number of moles divided by volume of the solution in liter we have told. Instead of moles, what we will consider here? Gram equivalents of the solute. That is the only difference. Then how to calculate this gram equivalent? See here. Normality is equal to, this can also be written as weight of the solute divided by equivalent weight of the solute. So gram equivalent is nothing but, remember, weight of the solute divided by equivalent mass, right? So just like here we will take mole is equal to mass divided by molecular mass, correct? In case of the molarity. But here we will consider weight of the solute, that is nothing but mass of the solute divided by equivalent mass. Instead of molecular mass, here we consider equivalent mass into 1000 divided by 1000 volume of solution in ml. So similarly here also we will do the same. Molarity also we are going to do the same. So here also volume of the solution in ml, because when you write 1000 here, we will write ml here. So that is about normality. So this is normality equation, very similar to molarity equation. Remember that very important point. Now unit of the normality is what? You can write it as capital N, like this capital M, or equivalent per liter or milli equivalent per ml. Here we call it as milli equivalent because ml, milliliter ige milli equivalent, liter ige equivalent. That is the only difference. Now, what is the relationship between normality and molarity then? See, equivalent weight. See, normality we want equivalent weight, correct? Equivalent weight can be calculated as molecular weight divided by N. So already we have discussed where N is valence factor. N is valence factor, it is different for different. For example, if it is there for you can say acid, divided by N is equal to basicity. If it is base, N is equal to acidity. If it is oxidizing agent, N is equal to number of electron lost or gained, like that. N is equal to valency factor. Now normality can be given as in with molarity equation, molarity into N. Remember, molarity into N if you do, you are going to get normality. Very simple one. Molarity into N is equal to normality. For example, remember, molarity of, just imagine molarity of sulfuric acid is equal to 2 molar. I want normality. Normality is equal to molarity into N value for H2SO4 is 2. Correct? N value for H2SO4 is 2. Hence remember 2 into 2 is equal to 4 normal, which means 4 normal is equal to 2 molar. So like this you can calculate relationship, very important relationship. Remember this molarity and normality relationship you have to know, right? like this, remember. Now, some important points we'll see. Like molarity in case of M1V1 equal to M2V2, right? So like this here also remember, normality equation can be written as, normality equation can also be written as N1V1 equal to N2V2. You can say after dilution, before dilution also. In case of the titration also it will help. If you calculate N1V1 for HCl, N2V2 for NaOH, like that also you can calculate. So remember. So another important, this is one formula. Another important formula you have to remember is, remember normality of the mixture of solution. Mixture of solutions of same substance, remember, of same substance. Normality of mixture of solution of same substance can be given as, remember, so N1V1, right, plus N2V2 plus N3V3 plus so on is equal to normality of the solution into V1 plus V2 plus V3 so on, like that. So this is about mixture, remember. So what they will ask is, they will give three different normality and molarity, the normality and volume, but they will ask you to calculate final normality of the mixture. This is N. All these things will be given. Remember, this is a first solution. This is a first solution. This is of second solution. This is of third solution, like that. So it will give rise to is equal to N into V1 plus V2 plus V3, that is of the mixture. Remember, like this you can calculate normality of the mixture of solution of the same substance. So this is about normality and equivalent mass. So thanks for the watching. Thank you for watching. Remember, share the video if you understand this particular concept. If you are not understood, please let me know. If you have any doubts regarding this particular thing, then please share and subscribe. Thank you. Have a nice day.